So in this lesson, we are going to learn how to solve systems of equations with linear and quadratics. So part one, this video is going to be how to solve them by graphing each type of equation. So remember that solving a system of equations just means more than one equation or function on a coordinate plane at one time. And we are looking for at what points on the graph do they intersect. Okay, so we've done this with just linear equations. Before this year, you graph one line, you graph another line, and you see where they cross, and that's the solution. Now we're actually doing it with a linear graph and a quadratic graph and seeing where they intersect, and that is still our solution, but it's going to look a little bit differently because it's going to be a straight line and a parabola. So remember that in y equals mx plus b form, slope-intercept form, that m value is the slope and the b value is the y-intercept where it crosses the y-axis. So in order to graph y equals x plus 1, we have to recognize that the slope is actually 1, or even 1 over 1, meaning the vertical value over the horizontal value. And the y-intercept is also 1, so we know that this line intersects the y-axis at positive 1. So I'm going to go ahead and plot that one. Then I'm going to do my slope from that point. So I can either think of it as going up vertically and 1 and then over horizontally 1, or I can think of it as going down and over in the horizontal direction. And remember, this is positive, so it's going to go this way, if you remember Mr. Slope Guy. All right, so if we carry this on, so I can make my line and connect my dots, we have done half of the problem, and we have graphed the linear equation. Now we have to graph the quadratic. And remember, guys, you can graph these and check your work with the Desmos calculator. So remember to use that link that I posted on Google Classroom. So our quadratic is in standard form, and there's a couple things that we know about quadratics in standard form right away. In my graph, I can know that this a value is negative, and that means it opens downward with a maximum value. So I know a little bit about the shape just by looking at that. I also know that this c value is 3, which means that it crosses the y-axis at positive 3. So I'm also going to plot that one. And we also know how to find the vertex in standard form. So in standard form, to find the vertex, the x value of the vertex, it's negative b over 2a. So if we do that for this equation, negative 2 over 2 times negative 1 would be negative 2 divided by negative 2, which would be 1. That means that's the x value of our vertex. Now, if I plug this x value back into this equation for all the x's, I can solve it and get a y value for the vertex. So 1 squared is 1, but then it's negative, so negative 1 plus 2 times 1, or 2, and then plus 3. So we have negative 1 plus 2 plus 3, which is 4, positive 4. So that means our vertex of this parabola is 1, 4. All right, so I'm going to plot that point over 1. Remember, you start at the origin, go over 1 in the positive direction, and up 4 in the positive direction. So this point is 1, 4. Now remember, if this is the vertex, that means it's the maximum value, and we know it opens downward. So I can already draw part of this curve. I know that this graph is going to go like this. Remember also that quadratics have an axis of symmetry. The line that divides it in the middle, and then both sides are symmetrical. So we can actually mirror every point we find on this graph. So if this is a point and it's 1 away from that, this is also a point, and we can go like this. The other thing we can do is make a table of values and just plug them in to the x and then solve for y. if we put in -1 in here, we would get 0, because -1 times -1 would be 1, so -1 minus 2 would be -3 plus 3 equals 0. So we know that -1, so back -1, 0 is also a point on this graph. And then I can mirror it. This is 2, length of 2 from that axis of symmetry, so I can go over 2 from here. This is another point on the graph. And so on and so on. We can fill this in. At 0, where do we hit? Well, 0, 3, we already knew that one. That's the y-intercept. 1, we also did 2, because 1, 4, that is the vertex. That's where we found the vertex. And so on and so on. We could do 2. At 2, it's up at +3. And 3 over 1, 2, 3, it's at 0. So what this means, and I'll just extend this down to finish my parabola. What this means is now we've graphed both and we can look at where they intersect, and those are our solutions. So right here, I'll get a different color. They cross at this point right here and this point right here. Those are 2 places, the only 2 places, in fact, that they share that are the same. And these points as coordinates would be -1, 0 for this one, and this one is 2, 3. So our solutions to this problem would be -1, 0, and 2, and 3. So that is how you solve a system of equations with a quadratic and a linear by graphing.